Now, coming to our next unit on network theorems. In the previous unit, you have studied mesh analysis and nodal analysis. They are reliable and extremely powerful methods. Both require a complete set of equations to describe a particular circuit. Even if we are interested only a particular voltage across a, or a current through a resistor or a source. So for such cases, so sometimes we are using these network theorems depending on the requirement, superposition or source transformation or Thevenin's, it will be more easier. So depending on your applications, so you can use any circuit analysis method. So it comes to the first network theorem, it's superposition theorem. The principle of superposition theorem states that the responses in a linear circuit having more than one independent source can be obtained by adding the responses caused by separate independent sources acting alone. This is superposition theorem. So this means at a time one source only will be active and how many other sources are there, they are inactive. That means the all other sources value should be equal to 0. If it is a voltage source, the voltage across that should be equal to 0. If it is a current source, that value of current should be equal to 0. So how can you make a voltage source or a current source equal to 0? So a voltage source, you can make it as equal to 0 by replacing the voltage source by a short circuit. Also a current source, you can make it equal to 0. That means current equal to 0 by making it open circuit. Now I'll just tell you about what is the concept of open circuit and short circuit. See, open circuit. Open means the circuit is open. See here, your circuit is open. You have a battery and a resistor. But see, the circuit is open here. If your circuit is open, can any current flow through it? No. Through an open, always current will flow through a closed path. So no current can go through an open circuit. So that means here there is no current. So current equal to 0. This is a open circuit. So remember, through an open circuit current will be equal to 0. See, if current is easily flowing means your resistance will be very low. So if it is open circuit means no current. So what will be the resistance between these 2 points? It will be very high or I can say infinite so that no current will flow through it. Now see here. See here I have provided a battery. I just no resistance is there through it. Just shorted it. So no, what is the voltage in this circuit? V should be equal to I multiplied by R. Is there any resistor? No. The resistance value here it is equal to 0. So if I am what is the voltage then? No resistance R equal to 0 means voltage should be equal to 0. So a short circuit means there is no resistance, zero resistance. So we can replace the resistance that source by a short. You can say it as short circuited and voltage across that will be equal to 0. So remember, a short circuit means voltage will be equal to 0 but current will be infinite. But open circuit means a current will be 0. For an open circuit current will be 0, resistance will be infinite. So to a circuit, suppose you have a current source in a circuit. Say a circuit, you have a current source and you want to make this current source is equal to 0. This current source I don't want, inactive I want to make. So that means I should ask current equal to 0 only when it is open circuit. So this will represent by the open circuit. So current source we are making it inactive or equal to 0 by opening it. Now suppose you have a voltage source. If you want to make, say I have a voltage source Vs here. I want to make this voltage source equal to 0 means I should short it. Say circuit complete. So this voltage source I should short it. So that means Vs is equal to 0. So a voltage source, if I want to make it inactive, means I should short it. A current source I should make inactive or equal to 0 means I should open it. So this is open circuit and this is short circuit. For a voltage source inactive, short circuit. Current source inactive means you need to open circuit. So this is the basic concept you should know before doing the superposition problems. So I will make superposition theorem more clear. Look at this circuit. How many sources are here? 1, 2, 3 sources are here. 2 voltage source and 1 current source. Look at all sources are represented inside the circle. So all are independent source. And here you need to calculate the current flowing through R1. You need to calculate the current flowing through Ix through R1. That is our question. So we are only interested in calculating Ix, the current flowing through R1. So now, as per superposition theorem, at a time we need to take only one source active and keeping all other sources inactive. A current source we can make inactive or 0 by open circuit it, as I told earlier. A voltage source we can make inactive by short circuit it. So now 3 sources are there. At a time I need to take only one source active. So now say Vs1. First source I am taking active. That means this source both should be equal to 0. This is a current source, this is a voltage source. So this is active means it will be there in the circuit. So that is your Vs1. Then your resistance. What about this? You don't have this source because this is a current source. It is equal to 0 means I should open it. So I don't have the current source there. Now what about this? This voltage source is equal to 0 means I should short it. So that Vs2 is equal to 0. Here it is open means I is equal to 0. So now see, you have R1, you have R2. I need to get this current. But actually Ix is due to 3 sources. Now I have only one source active. So I cannot write that is Ix. So I will represent it as Ix dash. So now you can calculate here Ix dash by your normal KVL, which is Vs1 divided by R1 plus R2. So I'm not interested in calculation. I just explain you what is superposition theorem. Now that is finished. Now what is the next step? Only second source is active. Second source is a current source. So Is is a current source and now this source is active. That means you have two sources. Voltage sources should be equal to 0. So this is equal to 0. It will be short circuit. Vs1 equal to 0. Vs2 equal to 0. So Vs2 is also equal to 0. And you have the current source. This is only active now. So it is 2 ampere current source. It is there. And you are interested in calculating the current thus. Now this is due to only the second source. So I will represent it as Ix double dash. So this is supposed to current. It is dividing to 2 branches. You can by using current division you will get Ix double dash. Now third step is third source alone is active. That means Vs2 is now active. Rest all other sources are equal to 0. So now this is there Vs2. So your resistance no change. This is 0. So that is not there. This is also 0. So Vs1 equal to 0, current Is equal to 0. Again, we are interested in this current, that is Ix due to third source Ix triple dash. So again, you need to calculate Ix triple dash by using KVL. So Ix triple dash. So what is superposition theorem? Superposition theorem means the actual current Ix due to all the three sources you can calculate by doing at a time one source active and getting Ix, then adding all the individual responses, that is Ix should be equal to Ix dash plus Ix double dash plus Ix triple dash. This is due to first source alone, this is due to second source alone, this is due to third source alone. You are adding all together 3, you will get your Ix. So actually you can see that if you are seeing this superposition theorem is little lengthier steps are there than compared to other things, but depending on the applications you can use it. Sometimes so many sources circuit becomes so complicated, in that case we cannot use it. The nodal mesh analysis, so in that case we have to go for the superposition theorem. Here we have an example problem. We need to calculate the current Ix through the 9 ohm resistor. We have two sources. So if you want to apply the superposition theorem, at a time one source is active. So first say your voltage source Vx is equal to 3 volt. That is now active. That means the current source should be equal to 0. The current source should be equal to 0. So how will be our circuit now? It is 3 volt voltage source. You have 6 ohm. You have here 9 ohm. And this will be equal to 0, means it is open circuit. So how can you calculate the current Ix? This is the current Ix shown by KVL, right? So this is plus minus, right, KVL. So 3 minus 6 Ix minus 9 Ix should be equal to 0. So we are getting Ix as 3 divided by 6 plus 9. So be getting it as 0.2 ampere. This is not Ix, this is due to only the first source. So Ix dash. I'll represent it by Ix dash. So that is the first source active. Now we will go to the second source active. So the second source is current source 2 ampere. This is now active. That means the first source is inactive. It is equal to 0. So that is represented by a short, and you have here 6 ohm and here the 9 ohm, and this is active. So it is there. You have the 2 ampere. Current source is there. And you need to calculate the current due to the Ix due to the source alone. So it is Ix double dash. So by using current division you can easily get it. So Ix double dash will be equal to the total current coming is 2 ampere. It is dividing to 2 branches. We are interested in this current. So it is 6 divided by 9 plus 6. So you be getting it as 12 by 15. So it is 0.8 ampere. So now we can find the actual Ix. So actual Ix is due to both the sources Vs and Is together. So actual Ix will be equal to Ix dash. It is due to the source 1 alone plus Ix double dash. That means 0.2 plus 0.8 should be equal to 1 ampere. So that is superposition theorem. Actually, see, if sometimes so many sources are there, we need to use this. This will make the circuit solving easier.